All right, what we're observing here is a skeletal structure of a formula. And so as a reminder, what we have to know about skeletal structures is they use lines to draw the structure, and that's a very messy one. And in those lines, at the junction, that's where two lines meet, we know there's a carbon. Let me draw one more line just so I have one more example. I'll draw one sticking out like that. So at each junction, we know there's a carbon, or at the end of a line like that, there'd also be a carbon. And not only is there a carbon, there's enough hydrogens to make 4 bonds. So carbon likes 4 bonds. So in skeletal structures, they take out the carbons and their associated hydrogens. So like on this one, let's see, on this one right here, it has 2 bonds and then 3, 4. Then this one has 2 bonds and so 3, 4. So you could go around each one. This one right here has 1, 2, 3. It would only have 1 hydrogen with it, where I'm drawing lines. Each of them are hydrogens. So that's what you have to remember fundamentally, is that every place that the lines meet or at the ends of lines, there is a carbon, and it's enough hydrogens on that carbon to give the carbon 4 bonds. Now this question, you actually wouldn't have to do any of it. Do you see it says connected to 4 hydrogen atoms? Well, let's think about that. So for carbon to be connected to 4 hydrogen atoms, it would be a carbon and then 1, 2, 3, 4. Okay, we're not going to find any carbons like this because a carbon like this one right here cannot be connected to anything else, right? If carbon has 4 hydrogens around it, it can't be in a molecule that has more carbons, or any other atom for that matter, because carbon can only have 4 bonds. So if we catch that quickly enough, we wouldn't even have to go through this molecule, which I'll go through it with you, but we wouldn't have to go through it. We would just check the box down here in the corner, because there's going to be no carbons in this structure that can have 4 carbons. 4 hydrogens, because if you have 4 hydrogens, you can't bond to anything else. So the answer to this one is that there's no carbons. Now we can verify it with ourselves. I'm going to go ahead with red, and I'll write in each carbon would be every place there is a junction or an end, there's a carbon. So there's carbons everywhere, like that. And then let's draw in their hydrogens, and I'm just going to start from the left and move right. So the first carbon that would have, I'll make the hydrogens in a different color. So the first one would have 1, 2, 3, because it already has 1 bond. The next one, this one has 3 bonds, so it would have 1. The top one would have 3 bonds because it has 1 or 3 hydrogens. This one next over, this has 1, 2, 3, 4. That would have nothing. 1, 2, 3. This has 1. I'm going around now. 1, 2, 3, 1. This one here has 1, 2, 3, 4. It wouldn't have any. 1, 2, 3, 4. It wouldn't have any. So now this one has 1, 2, 3. It would have 1. These at the end would both have 3. So we can verify the most that any of the hydrogens in this structure have are 3 hydrogens bonded to it, right? Some have 0 and a couple have 1. So this answer, and you wouldn't have to do all that if you thought about it, but if you did it all through, then you'd still get the same answer. So I hope that helps.